I would like to thank scientific committee for their invitation, and also I would like to thank the audience for their patience for this time. Good afternoon. My presentation consists of two parts. First part, I would like to give brief information about the restoration project of Kahramanmaraş Grand Mosque from February 6 earthquakes to this day. And in the second part, I would like to tell how earthquakes changed the conservation mentality in Turkey before and after the February 6 earthquake. After the February 6 earthquake, Directorate General of Foundation, Vakıflar Genel Müdürlüğü, invited me to participate in scientific committees in historical structures in the earthquake region. So I am responsible for many historic mosques in the area. And I came here several times in a year in Maraş or Kilis and Elbistan and Antep. So this is my content I mentioned before. Structural engineers love to show this map in their presentations because these red colors and orange colors show the danger of the seismicity of the Turkey. 85% of Turkey located in very severe, dangerous seismic zone. But unfortunately, after the earthquake, we immediately forgot where we live. February 6 earthquake is very unique earthquakes. In calculations, in structural calculations, we use this spectrum graphic, and briefly, this red line shows the limit that we use accelerations in our calculations. But you see these gray lines shows us that they exceed the limit. Also, they exceed the code limit. So this shows the magnitude of this earthquake. And on the right side, also in the map, we show a rupture on the fault line, and also it affects very huge area. Unfortunately, this picture shows that the minaret collapsed on top of the roof of the mosque. Historically, this mosque was built in 15th century, and in 5 periods, faced with several renovations and restoration projects because of earthquakes and fires and something like that. But the important thing is in between 2006 and 2007, the last renovation project was held. It's just about nearly 15 or 16 years ago from this time. Is this, I think, this is the PDF version. Also, I have the PowerPoint version because, okay, thank you. Okay, after this day, after the earthquake, a comprehensive study started immediately. These are the drawings that board approval with dates. The survey project was started immediately to get the information from the mosque, from the archives, from the thesis, from the photographs, because it's very important to documentate this mosque in archives. So survey project started. You see also damages on facades of the walls and all the damage, all the cracks on the walls of the mosque. And 2024 restitution project was approved. Before 1945, in the time period of the history, we saw that the roof type was slightly different. The mosque had a different roof type, but the restoration project was approved, the current version of the roof. As I mentioned before, the minaret collapsed on the entrance portal of the mosque, so it gave a severe damage to the mosque. Also, all of the facades got cracks and damages. These are the photographs inside the mosque. Also, you see how the plasters fall from the surface of the walls because of the magnitude. This mosque is very unique for these stone columns, stone pillars, and also these magnificent timber beams with ornaments, with drawings. It's very unique for this mosque. Or also the kürsü, mihrab, and minber are very unique identities. So another damage is the replacement and the movement of the columns at the base line of the pillars. You see the damages and the movement because of the earthquake effect. After the earthquake, we try to get observation and we try to diagnose the mosque very well. So we did some openings to see the compounds of the wall and also to discover the lintels, timber lintels in the wall. These pictures taken from the west side, west facade of the wall. At the left, you see white mortar injection at the left picture. This injection belongs to 2006 restoration. It's a kind of hydraulic lime injection. And also, another point, you see the rotted timber beam on the picture. This picture told us a lot of information from the mosque because this lime injection didn't work properly. It filled the gap, it filled the voids, but there were the bonding between the earth structure and the mortar structure. Yes, it filled properly, but it didn't bond the mixture very well. So another picture belongs to inside of the minaret, and also you see the cracks and deformation. Another observation got from the minaret is generally in earthquake zones, we use vertical and horizontal metal clamps to connect stone together. It worked very well in earthquake zones, but in this minaret, we only discover insufficient corrosive horizontal metal clamps. We didn't find any vertical metal clamps. Especially vertical metal clamps works efficiently in earthquake zones. It takes the horizontal forces as I seen in the picture. So after the earthquake, documentation studies started immediately. These are the pictures from the scanning. Because of the heavy damage of the minaret, board decided to remove the minaret, and these are the rubble cleaning and classification of original stones. When we remove the stone parts from the minaret, also we classify it because if they have sufficient compression capacity, we will use this stone again in reconstruction project. At the same time, ground survey studies started because as a structural engineer, it's very important how you settle and your foundations, they are directly affected to earthquake capacity. This is another technology we use in nowadays. This is the GPR technology. With this technology, we can define the void ratios of the walls, structural walls, and also we can define the which amount of injection we used in our walls. So the west facade post ratio is about 20%. There are 20% gap, voids, and emptiness in the structural walls in this scenario. We know that after the major earthquake, we face with other small earthquakes, so we have to provide a safe environment for research and workers. This is the metal shoring to keep the structure safe. The work is work in it, and also the researchers do their studies. These are the shoring project. Again, classification of original stones of minarets. We use these stones again. And restoration projects takes too long. It takes time to make this project. So to study in 1 year continuously, we have to build a protection roof. So these are the foundations of the protection roof of the project. And May 2024, we started to erect the structural system of protection roof. After the erection of our protection roof, we made some observation on top of the walls, and these are the structural ingredients of the masonry walls. This is double leaf masonry walls. Inner and outer sides consist of more decorative and more compressive resistant stone material, and inside we put some rubble, masonry, earth and lime inside the wall to provide the bonding effect. So to this time we realized that there are some gaps, there are some voids inside the wall, and previous injection didn't work. So we decided to make some experiments in 2 universities to get the proper injection, to get the proper ingredients, and to get the effective injection project to protect the structure. These laboratory tests were conducted in İzmir Institute of Technology and Mimar Sinan Fine Arts University, my university. So in the site, in the Maraş, the responsible company prepared wall sets in the site. These wall sets are identical to the walls in Kahramanmaraş Grand Mosque. They are same type of walls. And when we casted these walls, when we built these walls, we transported to İzmir Institute of Technology for structural tests. We injected different mixtures and different compounds to find the proper injection ratio and the proper injection ingredient. So these are the pictures from the site. Also, we try chemicals, acrylic, to get better bond between the materials. And also, we conducted electron microscope tests, how the material penetrates and how the material bonds together. These are the stages how we apply injection project to our wall sets. These are another GPR scanning. When we apply the injection, then we control the sets if it fills the gaps or not. So we will be assured the methodology with these laboratory tests. And finally, diagonal completion tests conducted at İzmir Institute of Technology. And we get the force and deformation results. And from these results, all these experiments resulted in 5 months. From these results, we chose the proper injection ingredient and the method. And now the company applied the injection to the walls of Kahramanmaraş Mosque. These are other photographs from conservation applications to the floor beams, also the drawings and other applications. Very severe damage zones, we have to remove these parts to reconstruct. These are the pictures. Also the injection. So I finished the first part. These are not all the repair and strengthening project, but from earthquake to this time, we started injection, we started timber conservation, and in future applications, we will apply some structural elements to the structure beams, lintels. So it takes time. We are asking your patience for this duration. So the second part is starting right now because okay, running out of time. Okay. So we use some guidelines when we approach these historical structures, and we follow these authenticity, reliability, compatibility, durability, reversibility, and monitorability parameters. But in restorations carried out in Turkey up to this time, especially focused on the principles of aesthetics and form, and unfortunately neglected the structural intervention. So, and unfortunately, it has been determined that many historical buildings that were collapsed or severely damaged during the February 6 earthquakes were restored in the near future, recently, before the earthquake. So these are all the pictures that renovated just a few years ago. A mosque from Antep, Elbistan Grand Mosque, Habibi Neccar mosques. What I mean, most of the time, structural engineers face with the question, is this application necessary or is this application unnecessary? So we have to follow the guidelines and codes in our country. We already have these guides and codes. So the principle is same for all the structure. If you make homogeneous, symmetric, rigid, simple structure, it works well in earthquakes. We saw it from Hagia Sophia. We know that historically Hagia Sophia dome was collapsed several times, and the great architect Sinan added additional buttresses. So it solves the problem until this day. Yes, it has it has affected view of the structure, but it works well. So we have some few samples before the February 6 earthquakes. This is from Şanlıurfa. The walls were strengthened with FRP. This is from Kilis Tekke Mosque. The dome was strengthened with FRP. Also, these applications applied with epoxy. Nowadays, we don't use epoxy. But what I mean, these structural applications work well. Also, this Battal Gazi minaret, I know that we can say a lot of things about the view of this minaret, but this minaret faced with two major earthquakes. In the beginning of 2020s, Sivrice earthquake, and it works. It didn't collapse. And also the February 6th earthquake, it didn't collapse. But if we use improper application, poor workmanship, this is also the same mosque, Battal Gazi Mosque in Malatya. Just before the earthquake, these buttresses were built, but you see how improper anchorage and corrosive anchorage, and just the renovated part was collapsed. So in nowadays, thanks to drilling technology, we use stainless steel bars to attach all the walls together. TRM, textile reinforced mortar technology, we can use. This is the roof of Kariye. And also reinforced minarets. Nowadays, we use continuous reinforced bars to improve the strength of minarets. We can apply it externally or inside of the minarets. This is the approved project of Hagia Sophia Fatih minarets. In a few years, you see this reinforcement on top of the surface. Also, I finish it in a minute. We know that the renovation completed, this is the Kariye, the renovation completed last year. In the renovation process, we discovered that this dome collapsed in 18th century, and they replaced this dome with timber dome, and it worked well again. So we use this technique in Habibi Neccar Mosque again. So we have to open new ideas and technological improvements in our work. Also, we can follow health monitoring. It works very well. It works very well. So the restoration of historic buildings requires a comprehensive approach, we know. Unfortunately, before the February 6th earthquake, we did a very less structural intervention to our historic structures, but this idea changed. February 6th earthquakes was a milestone for these things. However, there are no still structural engineering members on conservation boards in Turkey. We have the professionals, we have the knowledge, we have the laboratories. I think all the disciplines should come together and find a method to follow the codes. Otherwise, the decisions is changed up to scientific boards, and very different decisions change up to scientific boards. Thank you very much. I would like to thank Republic of Turkey Directorate General of Foundations, and these are the references. Thank you very much.